All right, this last page, we're going to talk about operations with radicals. And in this example 3, we're going to do multiplication with radicals. We're going to simplify where possible. One of the things that's going to make this work is remembering that the square root of x times the square root of x, or square root of a times the square root of a. You can do whichever you want. If you want to do an a under there, you can. Square root of a times the square root of a is a, because the square root and the square root undo each other. All right, so that's what's going to make a lot of this stuff work. Okay, 2 square roots of 5 times the square root of 10. That's going to be 2. Oh, I can make that the square root of 5 times 10 because we have a property that allows us to multiply those radicals. Remember, square root of a times the square root of b is the square root of ab. So we've got a 50 under there. So we've got 2 square roots of 50. Now in that 50, there's a 25. There's a 5 and a 2 in that 10. So we've got 25 times 2. 25 comes out as a 5, multiplies with the 2 that's already out there. 5 times 2 is 10, and we've got 10 times the square root of 2. So 2 times the square root of 5 times the square root of 10. So this is equal to that. They would have the same numerical value. If we find the decimal approximation, or the decimal answer, sorry, if we expanded them to decimals, they would be exactly the same. Okay, for part B, we're going to distribute because we have this subtraction sign right here. So we're going to do square root of 2 times 3 square roots of 2 minus the square root of 2 times the square root of 6. All right, so square root 2 times square root 2 is going to be 2, and the square root of 2 times the square root of 6 is going to be a 12. So here I have 3 times 2. This is a 2. 3 times 2 is 6. And then the 12, I can make that a 4 times a 3. And the 4 comes out as a 2. 3 stays underneath. And there's our answer. Let's try one with the cube root. Cube root of negative 4 is the same as the negative cube root of 4. So first thing, when I have a cube root of a negative, I'm going to pull that negative out in front before I do anything else. Now remember, we're always thinking. So now we're going to distribute. We've got the cube root of 4 times the cube root of 2. And then we've got negative and negative make a positive now. We're multiplying a negative times a negative as we distribute, right? So that becomes a positive, and we've got the cube root of 4 times the cube root of 16. Now I want you to look at that 4 and 2. 4 is 2 times 2. So that 8 is going to be a 2 cubed. 16 is 4 times 4. So that's 64 that I have. 4 times 16 is 64. That's going to be a perfect cube as well. 4, 4, and 4. 4 to the third power. So the cube root of 8 is 2. Cube root of 64 is 4. We get 2 plus 4. Our final answer is 6. All right, part D. 3 square roots of 5 squared. Notice the parentheses. That means we take 3 square root of 5 and we multiply with itself. This is not the only way to do this, but this is one way. We get 3 times 3, and then square root 5 times square root 5. 3 times the 3 is a 9. Square root of 5 times the square root of 5 is a 5. So our answer, 9 times 5, which is 45. All right, part E. And the rationalizing denominators, this is going to be for the honors. This will be the end of the notes for secondary T regular. So we have 2 square roots of 5 minus 4 times another 2 square roots of 5 minus 4. So we're going to multiply this out like it was a binomial multiplying with a binomial. So we're going to do 2 square root of 5 times another 2 square root of 5. So that's 2 square roots of 5 squared. Then we're going to have this 2 times negative 4 is negative 8. Notice I can kind of treat that square root of 5 like a variable a little bit. And we're going to multiply these guys. There's another minus 8 square roots of 5. Negative 4 times negative 4 is positive 16. Okay, 2 squared is 4. Square root of 5 squared is 5. So that's a 20, because that's 4 times 5. Minus 16 square roots of 5. And then plus 16. Notice how I did that one? Square the 2, square root the square root of 5. 20 plus 16 is 36, and then minus 16 square roots of 5. And we are done. Okay, part F. And that will be the end for the regulars, and for the honors, I'll do another video with rationalizing denominators. Okay, so do you notice that these are both square roots? The index is a 2. We don't write it, but the index is a 2. It's a square root. And the radicands are the same. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember what we said. The square root of a times the square root of a is a. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. This would be a lovely ACT question. And that is the end of the video for honor, or for regular honors. We'll have another video.